So now we are proving that sine square theta times cot theta times sec theta is equal to sine theta. So from the left hand side, so we are seeing that we have sine squared theta. So basically, when you're proving such identities, you express them in the known identities. The known identities, when you look at your calculator, you have sine, cos, and tan. So whichever trigger identity that is not in that form, you express it in that that form. Now when you look at ours, we have the cot and sec. So those ones we don't have them on the calculator, but we can express them in the form of sine and cos. So this is going to be, from the right hand side, we shall have sine squared theta times cot theta is the same as 1 over tan of theta. Then times sec theta is the same as 1 over cos of theta. So this one will be equal to sine squared theta times, now 1 over tan is the same as 1 over, so tan is the same as sine over cos, so it will make a reciprocal. It becomes cos theta divided by sine theta, then times 1 over cos of theta. So this one is going to give us, now are you seeing that one sine here will go with one sine here, and this cos will go with this cos here. So we shall remain with what? We shall remain with sine theta as required. So now here we are proving that tan x plus sec x over sec x into 1 plus tan x over sec x is equal to 1. So as I've told you in the previous example, that we have to express these ones in the form of sine and cos and tan. So that is the first thing we are going to do. So when we look at this, we shall have here proving that this one is equal to 1. Now where there is tan, I'm going to put sine over cos. So it will be sine x over cos x plus sec is the same as 1 over cos of x, then all over sec is the same as 1 over cos of x times bracket 1 plus, now our tan is the same as sine x over cos x, again all over sec is the same as 1 over cos of x. So this one will give us what? So when we take the LCM of the numerator, we shall have cos x is common, so up we shall have sine x plus 1 plus 1. Then this one is all over, it is all over, so 1 over cos x bracket. Now simplifying the bracket, so we shall have 1 plus, so this one is the same as sine x over cos x. Now if we introduce the multiplication sign, it will be times cos x over 1. So we are seeing that our cos x is going with the cos x. So we shall remain with what? Sine x plus 1 divided by cos x all over 1 over cos of x times bracket. So in bracket we are left with 1 plus sine of x. So implying that we shall have our, now bringing this one into the denominator, to be linear, so we shall have sine x plus 1 over cos of x. So now it will be divided by Now this one is the same as 1 plus sine x over cos of x. Now changing the sign and reciprocal, we shall have sine of x plus 1 over cos of x times, so cos x divided by 1 plus sine of x. So this cos will be cancelling this cos, then also this one with this one, which will give us a 1. So as required, so we have proved that. So we are having our last example on this. So we are proving that this 1 minus sine x over 1 plus sine x is equal to, under a root, is equal to sec x minus tan x. Now when you find such, so basically what you can do is you make use of the knowledge of rationalization. But now when I look at what I want, I'm going to rationalize this, but now using the what? The numerator. So I'm going to rationalize my equation. Sorry, I'm going to rationalize the denominator. So obtaining using the knowledge of rationalization. So rationalization means you get the conjugate. Now for example, my denominator is 1 plus sine x. So its conjugate will be 1 minus sine x. So I multiply it up and down on the what? This. So this one is going to be, so this one under a root is going to give us 1 minus sine x into, now 1 minus sine x. So you know I'm getting this, I'm getting the conjugate of the denominator, which is 1 minus sine x. I multiply it up and down. So all over 1 plus sine x into 1 minus sine x. So this one will give us, so I'm opening the brackets, what are you going to have? We shall have 1 minus sine x, but what? But squared, over, now this one is a difference of two squares, so which will be 1 minus sine squared of x, but now under a what? A root. So we shall have, now I think that, so this one and this one, they are different, so you cannot cancel them, so you must be very careful. Some students will make a mistake and say this one is 1, then they cancel. No. Now when you look at our denominator, using our equations, the other equations we had of cos squared x plus sine squared x is equal to 1. Now here we have 1 minus sine squared, so if we bring sine this side, it will be cos squared x is equal to 1 minus sine squared. So where there is 1 minus sine squared x, we are going to put cos squared x. So it will be 1 minus sine x but squared all over. Now here we are putting cos squared of x under the square root. So after having that, now, so square root means a half. So this one is the same as root of 1 minus sine x but squared of root cos squared x. And another thing I want to clarify about, Okay, I'm going to clarify on it at the end after finishing this. Now, so this square will go with the root, and also this square will go with the root. So we shall have 1 minus sine x over cos what? Cos x. Now, when you look at what we are proving, is sec x minus tan x. So what I can do, I can divide through by cos. Oh, I can separate this. This one is the same as, you can divide through by the cos, or you can separate. This one is the same as 1 over cos x minus sin x over cos x. So you'll have what? 1 over cos is sec of x minus sine over cos is tan of x, so as squared. So basically that is it. So what I wanted to clarify about is the case of cos. For example, you're given, let me use cos squared x and cos x squared. Now when you look at these two identities, they are totally different. So most students make mistakes from here. They think this one and this one, they are the same. So this one, cos squared x does not equal to cos x squared. So you must take note of that. So cos squared x is the same as cos of x, but the whole of it what? Squared. But cos of x squared means only x is what? Squared. So only the value of x is squared. So you should take note of that. So thank you for watching this video. Feel free to subscribe and share the link to others. So and turn on the notification button for other notifications. So we upload other more videos. So follow us in the next subtopic under the same topic of trigonometry. Thank you for watching.